One of the number one questions I get in the gas law unit is, what formula do I use? Well, lucky for you, on the back of your periodic tables, you actually have this entire list of formulas listed for you under a section called Behavior of Gases. There's one really important feature about each of the formulas that you want to make sure to watch out for, and really I'm talking about these three formulas to start off with. So just the first three in the beginning are the ones that are important to you. Well, the first formula only includes different pressures. Now, PT stands for total pressure of a gas. This can also include the atmospheric pressure. And then each of these other P's in the formula basically represent partial pressures. So you see that word partial pressures here. And usually when you see a problem dealing with only pressures or even specifically saying the words partial pressures, you would know to use this first formula. For the second and third formula on this formula card, it would be helpful if you set up that chart with the ones and twos and then down the center PVTN, because then you can see if you only have one P, one V, one N, one R, and one T, actually not the R, just one T, you'll know that you should be using this formula called the ideal gas law. If you end up with the chart 2 P's or 2 V's or 2 T's or 2 N's, that's an indication you would need this formula. As for these three formulas can actually be combined together to form this formula, which is called the combined gas law. But just in case you're curious, this is Boyle's law, this is Charles's law, and this is Avogadro's law. Now, for some reason, Gay-Lussac's law is not included on here, but you can still use the formula for Gay-Lussac's law from this combined gas law formula. So now, in addition to just knowing what the formulas are, I want to give you some tidbits that can help you be more successful. The first tidbit is going to be related to the temperatures. As you can see, several of the formulas have T's in them, which represent temperatures. And so on the other side of your formula card, you're going to see that there are other little things back here that can really help you out. In this highlighted section, I show you that 0 degrees Celsius is equal to 273 K. That's a conversion between Celsius and Kelvin. You will always solve your problems in Kelvin. Regardless if the problem tells you to solve, to show your answer in Celsius, you will always solve your problems in Kelvin. Other things that are important to you is this STP here, standard temperature and pressure. That's just a very specific temperature of 0 degrees Celsius and 1 atmospheric pressure, 1 atmosphere in pressure. Another little piece of information here is that 22.4 liters per mole is equal to the volume of an ideal gas at STP. So given these two conditions, 0 degrees Celsius and 1 atm, the volume of an ideal gas will be 22.4 liters per mole. Other things that are very, very important to you are these conversions here between atmospheres, millimeters mercury, and kPa, which is kilopascals. And then finally, we have this ideal gas constant, a value called R. The value R is used in the formula, the ideal gas law formula, PV equals nRT. And as you can see, there are actually 3 different values. And the big difference between these 3 different values is that there are different units of pressure in each of the numbers. So depending on the rest of the problem, if the P is in mmHg, millimeters mercury, then you're going to use this number here, 62.4. If the pressure in the problem is in atmospheres, ATM, then you'll use this number to represent R. Okay, so that's it for this little tutorial. You can go ahead and watch the other ones now to actually see practice problems.